Hello, welcome to physics class once again. My name is Olujimi Gabriel. This morning we'll be talking about projectile motion. Projectile motion. Now, this is a typical example of a projectile motion. A motion that the path is always in parabolic motion. But before we move into the topic fully, here are the objectives. At the end of this topic, you should be able to identify a projectile motion, derive formula for range, maximum height, and time of flight of a projectile. So the three key points we'll be looking at as far as projectile is concerned. Then note the application of projectile in life. Now, what is projectile? A projectile is an object launched into the air and allowed to move freely under gravity. Now, look at this ball. Now, when you project it forward, it will move down. As you can see, the path is always parabola. It's called trajectory. Now, from this point to the point it lands on the ground is called range, and the time to reach that point is called time of flight. This is the height of the hill or a cliff, whatever the case may be. The path of a projectile is parabola or curved path, just like what we have here. Now, this is one part. By the time we go further, we see some example of a parabola of this nature. Now, this one is being projected from the top of a hill, while this one is projected at an angle from the ground into the air. Here as the example of projectile motion, but you can think of some other sports that has parabolic in nature. Now, look at the first example that we'll be looking at here. This is what a projectile looks like. When a player kicked a ball at a particular angle, it moves in a parabolic nature. Now, look at the second one. When you throw a basketball from this point straight into the net, and this is done at a particular angle, and the height to which must be taken into consideration, and the range, that is the horizontal distance. And this is another example of a rocket that has been launched into the space. Now, an object under parabolic motion is subjected to two independent motion. Now, this is a particular ball under projectile motion. Now, the velocity, it has two velocities which are independent. Now, one is called horizontal velocity, the one that is in horizontal motion, while the one that is vertically downward, we call it Vx and Vy. Now, when you have any ball thrown from the top of a hill, this is the path. Now, at every point, it has two independent velocity. One is facing this side, one is always downward. This one that is downward is acting in accordance with gravity. Now, hence, any projectile in flight is doing two things. One, flying horizontally with a constant speed. Two, moving up and down with acceleration g. These are what? Gravity. The value is always constant, which is 10 meters per second square. Now, you can see that in this diagram. This is the original ball. This part have horizontal motion as well as vertically downward motion. This one is moving with a constant acceleration due to gravity, while this is moving with constant speed. Now, from our equation of motion, we have linear motion and we have motion under gravity. The same thing still apply, it's just that everywhere you have A, it has been replaced with G because acceleration due to gravity is in play here. Where V is the velocity, then the final velocity, while U is the initial velocity, A is the acceleration, and T is the time taken for the motion, where S is distance. Everything remains here, but we have plus or minus. Plus or minus is telling you the direction of the motion. Is it vertically upward or vertically downward? If the motion is against gravity, that means our G will be negative. But if the motion is in direction of G, of gravity, our G will be positive. That is why we put plus or minus G. Example 1. A tennis ball is projected horizontally from the top of a vertical cliff 50 meters high with a velocity 10 meters per second. 1. Find the time taken to reach the ground. The vertical component of the velocity, the distance from the foot of the cliff to where it hit the ground. Now, this is the diagram. From this top to this top is projected horizontally from the top. This is the top. This is the horizontal velocity, 10 meter per second. Now, this is the range. The height here is 50 meters. Our G is 10 meters per second square. We have to find the velocity, the time it reached the ground, the vertical downward velocity, which is Vy, and the horizontal distance. Don't forget, at maximum height, your initial velocity is equals to 0. That is, Uy equals to 0. Then we can find our Vy. Vy means it is vertical. That is, at maximum height, this is the maximum height here, our velocity, initial velocity, is equals to 0. Then we cannot calculate for our vertical component of velocity. Now, look at. This is the formula to calculate for height. So, from here, we know our Uy equals to 0 multiplied by T. We have H, we have G, we have U. T is missing. From there, we can calculate for our time. I choose to use the second equation of motion because it best suits the parameter I'm having from that question. Now, look at H equals to 50, U equals to 0, and T, which we are looking for. Our G is 10 and T square. By the time you multiply 0 to T, to give us 0. Now, that means 50 equals to T square. By the time you cut, it will give me 5. That means 50 equals to T square, 5T square, sorry. Now, by the time you make T square, so with the formula, we have T equals to the square root of 10. That is, T square equals to 50 all over 5 equals to 10. By the time you find the square root of 10, it will be 3.16 seconds. That is, it took the ball 3.16 seconds to reach the horizontal ground. Now, the vertical component of velocity, I can use the first equation of motion. Vy is what I'm looking for. I know from at maximum height, Uy equals to 0 plus gt. Because the motion is downward, is in the same direction with G. That's why I'm using a positive here. Now, U equals to 0, like I said before. What's our G? 10. Our time is what? 3.16 from here. Now, when you multiply, our vertical component of velocity is equals to 3.6 meters per second. Thirdly, the horizontal range. From our knowledge of distance and velocity, we know that velocity equals to distance over time. By the time you make distance with the formula, you have distance equals to ut. You can ut. S equals to ut, where u is the horizontal velocity, because we are looking for the horizontal distance now. So we use ux. Here we have been using uy, which is vertical. You can see the motion is independent. We have horizontal and vertical. So since we are calculating for the horizontal distance, we use the velocity in the horizontal component. Now, what is our u? It's equals to 10. And our t is 3.16. So our horizontal distance equals to 31.6 meters. Example 2. A ball is projected horizontally from the top, just the same question to what we did before. But just that this one is different. We are calculating for only one thing here, which is what? The height of the hill. We use the same equation that we used the other time. H equals to, since we are looking for the height, that is vertical motion. Now, our height is what we are looking for. Like I said before, u at maximum height, u equals to 0, t, 1 over 2 times 10 times 5. The time it took to reach the ground is 5 seconds. So you square the time. Now, this is 0 plus, by the time you cut, it will be 5. That is 5 times 25. Our answer is 125 meters. That is that. Now, let us consider a general case where the ball is being projected from the ground into the air and come back to the ground again, although at other distance. Now, the vertical height, the maximum height is here. At maximum height, say v equals to 0. Now, distance from here to here is called range. And the time it's from here to here is called time of flight. Now, this is the formula to calculate our time of flight. Time will not permit us. We would have derived this formula, but you can choose to do that at home. Now, this is the time to calculate, formula to calculate our time of flight, where u is the initial velocity, what you have here, initial velocity. 2u sine theta all over g. For the maximum height, u square sine square theta all over 2g, where theta is the angle the motion makes with the horizontal ground. And range is calculated using this formula. R equals to u square sine 2 theta all over g. That is, to know your range, if your target is here, you have to calculate the angle you are aiming, the angle to aim, then the speed of what you are projecting. Now, for maximum range of value for sine 2 theta is equals to 1, that means to have maximum range, your angle of projection must be 45 degree. By the time you multiply 45, it will be 90. Sine 90 is equals to 1. Any other angle more than this or below will not be maximum value again. Now, time of flight is the time required for the projectile to return to the same level which it was projected, just like what we have here. This is where it was projected from. This is where it comes back to the horizontal level again, the same level. The time it took it spent in the air, what you call time of flight. Now, the maximum height is the vertical height. This is the maximum height. Distance as measured from the horizontal projection plane. This is horizontal projection plane. Then range is the horizontal distance from the point of projection, this is the point of projection, to the point where the object hit the projection plane again. This is the projection where it hit again. The distance from here to here, we call it range. That is that on time of flight, maximum height, and range. Example 3. A projectile is fired with an initial velocity of 100 meters per second at an angle 30 degrees. Calculate time of flight, maximum height, range. In this topic, what you require is just to know the formula and apply. Now, this is the diagram. A projectile is fired at an angle to this is the horizontal. Is fired at this angle. This is the initial velocity u. This is the angle 30 degrees, and your u is equals to 100 meters per second. Now, this is the formula to calculate our time of flight. This is the formula to calculate our time of flight. Once you know the value for u, which is 100 meters per second, and the theta is equals to 30 degrees, every other thing, we know g to be 10 meters per second, then you slot in your value there to get your time of flight. Now, 2 times, our u is 100. 2 times 100 times sine, value of theta is 30. That is that. Now, when you cut 10 in 10, it will be 10. That's why we have 10. And sine 30 will give you 0.5. 2 times 10 times 0.5, you have 10 seconds. The answer is 10 seconds. Now, the next thing is maximum height. And this is value for maximum height. U square sine squared theta all over 2g. Now, like we did here, we slot in all our values to get maximum height. Our u is 100, you squared it, times sine square 30 degrees all over 2 times 10. This is 2, where g is 10. Now, when you square 100, it will give us 10,000. Divided by 20. This is what you have. Our answer is 125 meters. By the time you square 0.5, it will give us 0.25 times 5 times 100. Now, let's continue. That is our maximum height. Then, our range is this. R equals to u square sine 2 theta over g. Now, just like the same way, 100 square times sine 2 times 30 all over 10. 100 square times sine 60. And what is sine 60? Sine 60 equals to 0.866. That is 100 square times 0.866 divided by 10. You can finish that one on your own to show that you really understand what we're talking about. Now, example 4. Just like the same way, a tennis ball is hit with a velocity of 3 meters per second at an angle of 60 degrees to the horizontal. Calculate 1. The time of flight, maximum height, and range. Take note your g is 10 meters per second squared. Now, just like the other question, this is our formula. You input your values since you know the initial velocity and the angle. That is the answer for the first one. Is equals to 0.25 seconds. Sorry about this mistake. It should be seconds. Then, our maximum height, you know your u to be 100, your u is 3, that is initial velocity is 3, and your angle is 60 degrees. Now, what do you have there? 3 square sine square theta should be squared all over 2 times 10. What do you have here? This should be squared. Your answer should be 0.39. I don't know, can confirm. Let's quickly confirm that if it's correct. Now, the answer should be 0.67 meters. It's an error here. This answer is not correct. Now, for the range, we have u square sine 2 theta all over g. Like before, you input your values. This is what you have for the maximum range. That is that on that question. Now, assignment. A ball is thrown horizontally from the top of a cliff 20 meters high. If the velocity is 8 meters per second, find how long it takes to reach the horizontal plane at the foot of the cliff. How far from the foot of the cliff it strikes the ground. The speed with which it strikes the ground. Another one. A ball thrown with a speed of 100 meters per second attain a height of 100 meters. 150 meters. Calculate the time of flight, the angle of projection, the range. Here you work from maximum height. Then you find what is missing there before you can find other thing. Another one. The range of a target is found to be 20 kilometers. A shell leaves a gun with a velocity of 500 meters per second. Full stop. What must be the angle of elevation of the gun if the ground is level? Just like a fighter jet is coming and it shoots, this is the target here. Let's say this is the vertical height, this is horizontal distance target. If it shoots something here, don't forget the speed. You find this, the angle here, just like you find your range, height, then you find your angle. That's all. It's as simple as that. Now, till I come your way next time, have a wonderful time.